Hi, today's job is fixing the starter motor on this MG ZS V6. So there's the starter motor located on the engine, same sort of location on all the engine variants I believe. So it's just a matter of getting enough access to get to the support bolts. So I believe we're going to have to get to that bolt there, which I think we can see. It's useful to have this foam with light on it. And there's also a bolt underneath the starter motor, which we shall see how we can get to that in a minute. So you need to remove the battery cable connection from the battery. Then you can safely undo this 13mm bolt that connects the main power feed onto the solenoid part of the battery. You can see I've already loosened up the motor, which takes us on to the two bolts that need undoing. And there are two 15mm bolts. Let's see if we can get into that again. One is there, a little bit out of focus, but it's difficult to focus. And one is right underneath. You're following this? Yeah, one is right underneath this bolt here. Both 15mm. Hopefully, if I zoom out, you'll be able to see the perspective of where that is. Go. So to get to those, the Haynes manual talks about removing this canister, removing the wheel arch liner. All that is rubbish, I think, because I've already managed to get to those two bolts from above, and all you need is a little extension with a socket, something like this, onto your torque wrench. Get the torque wrench positioned in the top, so you need to have a socket extension just about the right size. Push a few wires out the way. Let's get in the right position with the video camera. There we go. And then you can get in to undo the top bolt quite easily, like so. For the bottom one, you have to wiggle underneath it a little bit, and should be able to get that underneath like so. I've already undone that one, loosened up a little bit. Once you've loosened it up, you can then use slightly quicker and easier to use a small wrench like so. So I've already loosened those up, and I'll just take the bolts out, and then we should be able to remove the starter motor in order to fix it. The problem with this starter motor was that it was starting to cut out on some parts of its rotation. So the engine starting was getting more difficult, very sort of jerky start, which makes it quite difficult to start. So hopefully stripping down the starter motor, we can repair it at zero cost. So also you need to remove the solenoid starter connection cable, the bit that actually engages the starter motor from the ignition switch. Pull back the cover on this main power feed and undo the 13, let's move it out of the way so you can see it. Yep, undo the 13mm nut that's holding the connection in place. Then all of the connections to the starter motor are then loose, and once the two bolts are undone, you should be able to remove the starter motor. Okay, once you remove these two bolts which hold the starter motor in position, then you can wiggle the starter motor out, as I've done here. Now the only awkward thing is, I'll get around the bottom a little bit, the only awkward thing is this little bracket that's got to be taken off one of the bolts. Gets in the way a little bit. And here it is, wiggled off. It's everything disconnected. And now we just have to get it out from under this space. So there we go. There's our starter motor out. Teeth on it are not too bad. So hopefully just cleaning up the electrics, the brushes, should bring it back to life. That's the next stage. Right, so here's the starter motor. It's a Bosch starter motor. The engine's only done just over 100,000 miles. Had this cap on the end of the starter motor removed by a couple of screws, and it looks like we have to take this clip off in order to probably then remove the casing from the motor. So we'll do that. Taking these two long bolts out from the end of the starter motor, so I'm hoping we should be able to just pull that off now, and indeed we can, like so. which reveals some gearing, and the actual motor itself is in here. So we can then pull out the rotating part of the motor. See, there's some pretty heavy wear marks all over the surface. It shows it's not particularly well aligned to the outer casing. Either that or rust has pushed the outer casing and made the clearance insufficient, but the metal is all worn off the surface, which is interesting. If you pull the rotating part out this way, all the brushes pop out, and it basically leaves a bit of a mess at the bottom. So really, the thing to do is take this top part of this top sheet of the motor off. This cap just pops off, and if you push up on the rubber, the brush assembly then removes like so. And all the brushes are obviously popped out at the moment with their enclosures. We'll rebuild all that later. And indeed, you can see some of the springs stuck to the magnets and so on, so I have to extract all those and rebuild them in a minute. The brushes themselves are not too worn, so that should go back okay. Here's the gearbox and cog mechanism itself pulled apart a little bit. It's a little bit stiff to turn this bit, so we'll give it a good spray using WD-40 oil and put some graphite grease around all the various bits later to try and free it up a bit more, but otherwise not too much wrong with that. So I've given the gear mechanism a good lubrication with a bit of light oil and WD-40, a bit of normal engine oil to have a more permanent lubricating effect, and some moly grease. Doesn't matter too much what sort of grease you use, I don't think, but stuck it in the gears, gearbox side, around the bearings on this side, and in particular put a bit of oil around by where my thumb is, and this well, it looks like some sort of bearing thing. And it seems like that when you try and push on these gears, you can hold this part stationary. In fact, if I show that now, yep, if it's rotating that way, this piece of metal down here roughly stays stationary, whereas if I push it the other way, it'll always rotate with it. Some sort of one-way bearing or something, and it's probably associated with a mechanism to thrust out the gear when the motor is rotating. It was very stiff in the normal operation, where it should rotate that way and this piece of metal stays stationary. Lubricates it a bit more, and you can see now works a little bit better. That may have been part of the problem. Maybe the gear wasn't being thrust out properly enough when the motor was engaged. So all cleaned up, lubricated, we reassemble it and then just test the resistance of the motor as we turn the gears around. So here's the reassembly of the brushes with metal spring and brush retainers in this sort of position, and the brushes themselves won't go all the way into the retainers because the spring is basically pushing them out, so we'll have to refit these as we fit it to the motor. So here's the motor part assembled, the outer casing on, included with the inner motor part. To fit the brushes, the easiest way is to fit a socket in the middle with just two brushes in position. Push the socket over onto those brushes and fit the remaining two brushes. Flip it over, fit to the motor, remove the socket, and then push the brushes back into the final position with a little screwdriver, like so. Then we add a bit more moly grease onto the shaft, position the end plate, like so. To refit the circlip at the end, it's probably useful to pop the motor off the gearbox temporarily, push on the shaft in order to poke out the end of the motor shaft in order to get the circlips back on. Right, here is the motor fully assembled with the two bolts evenly tightened through the motor shaft, end bearing cap put on, bit of moly grease also put in there as well, and the solenoid connection. So once it's reasonably lubricated, should be able to easily move the gear this way, and it should be able to just about, with some difficulty, move the gear towards that direction, towards you. So there seems to be a sort of one-way gearing mechanism in there, or device. Something to do with this bit here. And I think the problem with this motor originally, that it just got a bit stiff and a bit unlubricated inside. So you could turn the motor over slowly by pushing on that gear, measure the resistance of the motor as I mentioned earlier down to the chassis, see if any of the coils are burnt out, but they're pretty juicy coils, so pretty unlikely, and the brushes seem reasonable. So what I'm going to do now is just test the solenoid of the motor, see whether it works. So I'm going to use the battery to do that. Don't worry, you're not going to get electrocuted because it's only 12 volts. So you need to connect the chassis of the motor onto the negative side of the battery, which we'll do just by touching the case against these terminals here. Make sure the cog of the starter motor is out of the way of both your fingers and any bits of metal. And I'm just going to use a screwdriver to connect the positive side of the battery onto the solenoid, like so, and you can see the motor is slowly turning over and the gear of the motor is pushed out correctly by the solenoid. It's only turning over slowly because what's happening is positive supply is going through the solenoid, activating the solenoid, current is going through and into the motor, and the motor is only turning slowly because the current is limited by the resistance of the solenoid. To get it to go faster and work in its normal operating mode, we're going to connect both the positive side, input side of the solenoid, and power to the solenoid at the same time. So if you get a screwdriver connecting these two bits together, and if you're lucky, position it correctly, you then connect it onto the positive side of the motor. The motor will then turn a lot quicker and a lot more powerfully. Let's see if we can do that. Like so. Don't worry too much about these sparks. Again, it's not high voltage, just a high current. That's why it's sparking so much. So there you can see the motor is fully operating correctly, reasonably lubricated. Don't go too mad with lubrication here, because what you don't want to do is get any oil or grease onto the flywheel to work its way onto the clutch, because this is going onto the teeth of the flywheel, which is where the clutch is situated. So now we'll just reassemble that back on the motor and check it out later. When reassembling the bolts, I'd recommend putting some thread lock, Loctite 243 on the threads, and reassemble it in the same way that you took it apart, obviously reverse order. And you need to tighten these bolts to 85 pound-foot. Right, that's the motor all reassembled. Now, final test, let's just see how well the car starts. Beauty! Turns over nice and fast, nice and reliably, starts well. That's it, okay, thanks for watching, bye.